Okay, think about this for a second. Right now, we are standing on a 5 billion-year-old ball of iron, oxygen, silicon, and magnesium, and it is hurtling through the dark void of space at an absolutely astonishing 67,000 miles per hour. We just walk around on it every single day, right? But the truth is, this home of ours is far more bizarre, extreme, and honestly fascinating than we usually realize. So it really begs the question, how well do you actually know your home? If you think you've got a pretty solid grasp on Earth just because, you've looked at a map a few times, well, prepare to have your mind blown. In this explainer, we are going to completely dismantle everything you think you know. Let's peel back the layers and dive into the extreme realities of our planet. All right, starting things off with Section 1, the visual illusion. When you picture Earth from space, you probably instantly see that classic, beautiful blue and green marble. But actually, it wasn't always that way. Today, plants use a green pigment called chlorophyll to harness the sun's rays. But way back in the days of early life on Earth, plants used a much more primitive molecule called retinol. And here's the crazy part, instead of green, retinol gave off a distinct bright violet hue. Yeah, Earth used to be bright purple. Millions of years ago, all photosynthesizing plants on our planet were purple. If you were an astronaut looking down at Earth back then, that iconic green and blue marble would have literally been a giant, vibrant purple sphere. It kind of completely changes how you visualize the ancient history of our world, doesn't it? And, speaking of visual illusions, let's talk about the actual shape of the planet. Every single school globe you've ever spun in a classroom, it's been lying to you. The Earth is not this perfect, beautifully symmetrical sphere. It is actually a shape known as a geoid. And the why behind that shape is pretty wild. The Earth spins on its axis at a blistering 1,000 miles per hour. That incredibly high speed creates a massive amount of centrifugal force right at the equator. It literally pushes the Earth and the water outwards, giving our planet what is essentially a cosmic spare tire. So yeah, we're basically hurtling through space on a slightly squished, bulging rock. Right along to Section 2, the uncharted depths. Let's transition from the physical shape of the planet in space all the way down to its vast surface waters. Astronauts famously call us the blue planet because 71% of our surface is water. But you'd think with all that blue, we'd be swimming in fresh water, right? Well, look at this breakdown. In reality, 97% of it is salt water. Of the remaining 3% that's fresh, 2% is completely trapped in ice sheets and glaciers. That leaves a tiny, microscopic fraction, less than 1% of all water on Earth, as accessible liquid fresh water in our lakes, rivers, and aquifers. And with water dominating so much of our surface, you would absolutely think humanity has mapped every single inch of it by now. But no, 95% of Earth's underwater world still remains completely unexplored. Just think about that for a second. 95%. It is a remarkable testament to how astonishingly vast and deeply mysterious our oceans actually are. It's honestly like having an alien world right here on our own planet. And because the ocean is so unexplored, we often totally miss its sheer scale. Like, if I asked you right now to name a massive mountain range, you might think of the Andes in South America. And hey, that's a highly respectable 7,200 kilometers long. But hidden right beneath the waves is the mid-ocean ridge system. And it completely dwarfs the Andes at a monstrous 60,000 kilometers long. This isn't just any mountain range. It is the single largest geological feature on Earth, and it spans the entirety of our oceans. It's essentially a 60,000 kilometer continuous chain of underwater volcanoes being constantly created by eruptions of basaltic lava right between the Earth's shifting tectonic plates. It's this massive, violent engine just completely hidden out of sight. Brings us to Section 3, the extreme engine. Now we need to shift our focus downward, piercing right through the crust to explore the really violent, fiery interior of the planet. The Earth is layered a lot like an onion. If we journey down, we pass through the crust we live on, down through the thick, rocky mantle, until we finally arrive at the center, the core. And this is where things get truly mind-blowing. So the crucial point here is that the core is mostly molten iron, bubbling away at terrifyingly toasty 6,100 degrees Celsius. That makes the center of our planet exactly as hot as the surface of the sun. But here is the ultimate paradox. Despite this sun-level heat, the very center of the Earth's core doesn't melt into a liquid. It remains solid iron. Why? Because the immense pressure from the crushing weight of the rest of the Earth literally forces it to stay solid. It is a true extreme of physics happening right beneath our feet. And while we've got a literal miniature sun trapped beneath us, we are simultaneously being bombarded from above. Space is actually incredibly dirty. Every single day, our atmosphere and surface are sprinkled with 100 tons of space dust and debris, mostly from comets and other planets. It's kind of like interstellar fairy dust, constantly raining down on us, totally unseen.
All right, our final section, Section 4, the cosmic miracle.
That space dust brings us perfectly to our final perspective shift. Let's zoom out, way out, to a cosmic scale. When we look at the interstellar scope, Earth is tiny, like really tiny. Fun fact, we're actually the only planet in our solar system not named after a mythical god. But let's talk size for a second. You could fit the Earth inside Jupiter 1,321 times. And if you really want to feel like a microscopic speck, consider this. Our entire world could fit inside the sun 13 million times.
But wait, don't let that make you feel insignificant, because our tiny, dusty little dot is incredibly special and utterly unique. It's the only planet we know of that has given birth to life. And that's because we have this ridiculously specific set of perfect conditions. We have the exact perfect temperature and proximity to the sun. We have liquid water. We have an active magnetic field that acts as a shield, protecting us from the sun's violent radiation, along with so many other perfectly balanced factors. Just take a moment to really process all those zeros on the screen. Scientists have actually calculated the exact statistical chances of all these specific factors coming together at once to create a planet that can sustain life. The odds are 1 in 10 septillion. That means against all those zeros, against the vast, empty, dirty, hostile vacuum of space, we beat the odds. Despite being a tiny speck with a molten core covered in mostly undrinkable, unexplored water, the fact that we are even here to begin with is absolutely nothing short of a mathematical miracle. So, I want to leave you with this final thought. Knowing the sheer statistical improbability of it all, knowing about the extreme sun-level heat right below your feet, the giant hidden mountains in our unexplored oceans, and the 1,000-mile-per-hour spin giving us our quirky spare tire shape, how will you view your fragile, beautiful, bulging home tomorrow? I really hope this explainer has given you a whole new appreciation for the absolute marvel that is planet Earth. Keep learning, keep questioning, and I'll catch you in the next one.